Permutation is a fancy word to describe a way of counting, specifically when we're counting and we're placing items in an order and arranging them in various different orders. Okay, so a few examples down here. You can see down at the bottom of the screen right there. You can see this word Wayfarer. How many different ways can those letters in Wayfarer be arranged? And basically that's what we're talking about here. So we're counting ways of placing things in order. Now, there's a formula for this, okay? So the permutations of n numbers in r different ways, all right, is given by n factorial over n minus r factorial. So minus r factorial. So that's the number of items n that are arranged r at a time when order matters. Okay, let's take a look before we start at the at this way of calculating factorial. What is a factorial? What is an exclamation point? You might see it in an older calculator. They're kind of hidden in the new graphing calculators in the within one of the functions. But this idea of factorial, it's not difficult to calculate. When it gets to bigger numbers, it just takes a long time. But all we mean when we talk about factorial is that we're multiplying. Starting at 4, we're going to multiply downwards. So we're going to multiply 4 times 3 times 2 times 1. Okay, and of course the 1 doesn't matter, but all the way down to 1. All right, and we're going to stop at 1. We're going to stop at 1. We're not going to go down to 0 because that would just defeat the purpose. All right. So 4 times 3 times 2 times 1, that's giving us 12 times 2 is, of course, 24. Right. This gets a lot easier when you have a calculator. You will excuse me because I do not have a calculator handy right now. I do have one on my computer. I might pull it up in just a moment because this one here is 8 times 7 times 6 times 5 times 4 times 3 times 2 and times 1. As you might imagine, that's going to be a much larger number. Let's take a look at what it is. Calculator. And hopefully you're quicker than I am. You've pulled up your calculator already. And we've got 8 times 7 times 6 times... Did I do that right? I don't know. Let's try that again. 8 times 7 times 6 times 5 times 4 times 3 times 2. There you go. 40,320. It's a really, really large number, okay? So 40,320. Okay. So here's one of those things that we want to we want to calculate how many ways that various different things can be arranged. Okay, so we're going to stick with factorial for just a moment while we examine this. So we look at how many ways can 10 students in a class form a straight line. Okay, so we're not looking at how many at arranged r at a time. We're not looking at this part of the formula just yet. Okay, we're just looking first of all at the full 10 students. So when we've got just arranging a full 10 students, all we've got to do is use our 10 factorial. Right? I don't think the calculator here has a factorial, but anyway. All right. So 10 factorial here is going to be 10 times 9 times 8. I'll try this again. As you can see, it's kind of difficult on a computer. 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2. And we can leave it at that, of course. We've got 3,628,800. So things get very large very quickly. Okay, all right, so that's just a brief overview of factorial, of what that looks like. All we're doing is we're taking the largest, the number we've been given, we're multiplying downwards all the way down to 1. Okay, now let's look at what that means when we start applying the formula. So with this question here, we're being asked how many ways can 4 out of 7 pictures be hung on a wall in a line. So we've got 7 pictures and we want to hang 4 of them. Right? So if you look at this formula, the number of, in this case, 7 items that can be arranged 4 at a time when order matters. Okay? So how many ways can 4 out of 7 pictures be hung on a wall? So in this case, we have a permutation of 7 items, right, in 4 different ways. Right? Okay? So the way we calculate that is we use our factorial. So we're going to use n factorial, which is 7 factorial, and we're going to divide that by n minus r factorial. So that's 7 minus 4. Calculate that first, and then we use the factorial on it. Okay, so let's clean this up a little bit. This is 7 factorial first of all, and down here we've got 7 minus 4. That's 3 factorial. Okay, now this kind of the whole division thing kind of gives us a nice little trick, which I kind of showed a little bit in the previous lesson when we were looking at probabilities, when we were looking at independence of conditional probabilities. What we have here is we've got 7 times 6 times 5 times 4 times 3 times 2 times 1, and that's divided by 3 times 2 times 1. Okay, and as you can see, above and below we have similar terms. We've got the same terms above and below. So this 3 can cancel out with this 3, this 2 can cancel out with this 2, and obviously the 1 can cancel out with the 1, not that it really matters. Okay, but the key idea here now is that we've just made things easier for ourselves. So now all we have to look at is 7 times 6 times 5 times 4, and that's it. It's just 840. So that gives us a total of 840 different ways. Right? So the formula is actually kind of working in our favor here, and it means we've actually got less ways because we're only choosing 4 items. We're choosing 4 ways to arrange them at 4 items to arrange at a time out of the whole lot. So let's look at another example. How many ways can the awards first, second, and third place be given in a group of 6? So essentially what we're doing is we're giving the 3 awards in order, right, 1, 2, and 3, to a group of 6, out of a group of 6 people. Okay, so we have a permutation here of 6 people, and we want to arrange them where order matters in groups of 3. Okay, so a group of 3 people where order matters. Okay, right. So what that means is we now have 6 factorial over 6 minus 3 factorial, and that of course is 6 factorial over 3 factorial. And if we work that out, it's going to be 6 times 5 times 4 times 3 times 2 times 1. I'm going to stop writing all of these all of the time in a moment and kind of give you a quicker way of doing it. We've got 3 times 2 times 1, and you see obviously that the 3 times 2 times 1 cancels above and below, and we have ourselves 6 times 5 times 4, and that's it. So we've got 120 different ways that you can award first, second, and third place in a group of 6. It's kind of remarkable, actually, when you think about it. If you've only 6 people in a race, 6 people running in a race, there's 120 different ways that race can pan out. Quite amazing, all right? At least that the prizes in that race can pan out. There are more ways, of course, that you could order the whole group, all right? Which we looked at earlier with just plain factorial. Right? Okay. But when we're looking at just choosing a few of them, we narrow it down. Okay. This question D kind of brings us to, it's really just the same. It's the same as just factorial. We actually have 1, 2, 3, 4, 5, 6, 7, 8. We've got eight letters there, so it's just 8 factorial. We're not asking to arrange it, 4 letters at a time. We're just asking the whole thing. So that's going to be, of course, we've got the answer above 40,320. Okay, so the key idea there is, like, you've got the letters in Wayfarer. You can arrange that 40,320 different ways, those particular letters, including the repetitions. But if we did something along the lines of saying, well, we only want 4-letter words out of the word Wayfarer, then we would have to apply our formula. So just be careful that we're not that you don't mix up the two. Let's move on a little bit and see what else we have going here. Not a lot. All right. So a few quick examples here. A few quick examples. While I have these here, I will of course put my formula right up here. So the formula right up here, and R is equal to n factorial over n minus r factorial. Right. So let's apply that in every case right here. So really quickly, this is just going to be 8 factorial over 8 minus 6 factorial, which is 8 factorial over 2 factorial. Right? And that, of course, is going to be 8. That's going to be, right down here, 8 times 7 times 6 times 5 times 4 times 3. We stop at the 2 because we're canceling those ones out. So let's plug that into our calculator. We get 8 times 7 times 6 times 5 times 4 times 3. And that's 20,160. All right. So this one is going to be a lot easier, actually. When we look at this one here, we got 6 factorial over, well, it's not easier. It's the further away the numbers are, the easier they are. Okay. So this is 6 factorial over 6 minus 5, which is 1 factorial, which is just 1. So this is just 6 factorial. So we can calculate that right here as 6 times 5 times 4 times 3 times 2. We don't worry about the 1. That's just 900 different ways for 6 factorial. I hope I got that right. So 900 different ways to arrange that one. This one here is going to be 7 factorial over 2 factorial. Right? Notice I'm just taking the difference now. Right? I'm not worrying about that there, right? And that's going to give us 7 times 6 times 5 times 4 times 3 times 2. And I'm going to do something here. I've got a 9 from the 6 factorial, 900 from the 6 factorial again. So all I'm going to do here is I'm just going to multiply this times 7. And that's going to give me 6,300. Okay? So that's 6,300. I'm taking a few shortcuts here. I'm recognizing that I already worked out this part. The 6 factorial. That was 900, so I just multiply times 7. Okay, and again, the same with these ones here. These are different here. This is just 1, 2, 3, 4, 5, 6. This one here is just 6 factorial, which of course is 6,300. Oh, sorry. I'm going to rewind just a little bit here for a second because I made a mistake right there. I included the 2, which is I should not have done. And I just noticed that because the 2 here, that's gone. So the 2 and the 1 are gone, right? So that means that I do need to recalculate this, of course. This is going 7 times 6 times 5 times 4 times 3. And that's 2,520, so 2,520. All right, so different ways that these letters can be arranged. This is just 6 factorial. That's the word. That's the 6 letters, so 6 factorial. That's equals to 900. This one here is 7 factorial. 1, 2, 3, 4, 5, 6, 7. That's 7 factorial. All right, so this time we can actually just multiply 900 times 7, because 900 is 6 factorial times 7 is 6,300. And Mississippi is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's 11 factorial. And we've already got 7 factorial here, so we're going to use it. So we're going to multiply times 8 times 9 times 10 and times 11. And that fits into our calculator, thankfully. That's 4, 9, 8, 9, 6, 0, 0, 0. So almost 50 million. All right. So that's a rough breakdown. The key idea here is the difference between factorial and, first of all, what is factorial, right? All you're talking about is multiplying, starting with the number all the way down to 1, right? And then using that in a formula to calculate how many ways this can be, how many way, when you've got 8 items, how many ways can you arrange 6 of them in a row? Okay, so there you go.